Hello everyone, I welcome you all to my online classes. This is Om Maths Corner. Today we shall discuss exercise 14.5. The name of the chapter is Mathematical Reasoning, class 11, subject Mathematics. So let us proceed now. The very first question of the exercise is The very first question of the exercise, show that the statement P is the statement if x is a real number such that x power 3 plus 4x is equal to 0, comma, then x is 0 is true. Number 1, direct method. Number 2, method of contradiction. Number 3, method of contrapositive. So one by one we shall discuss these methods. The very first method, direct method. How to solve? Direct method mean P implies to Q. Okay, this is the direct method. So how we solve this? What is given? X raised to power 3 plus 4x, this is equal to 0. This is P, this is given. So from here this implies x, taking x common, we are left with x square plus 4 is equal to 0, right? Now two things happen. This implies either x is equal to 0 or x power 2 plus 4 is equal to 0. Okay, now what happens? This is false, this is false. Why this is false? Because this is given that x is a real number. Because as x is a real number and square of any real number cannot be less than 0. Here what we see, x square is equal to minus 4, that is negative. So we reject this second bracket. So what is the conclusion? Conclusion is x is equal to 0. So this is what we want to prove. Then x is 0. So this was direct method. Now second method is method of contradiction. Second method, method of contradiction. How to use this method? What is the statement? If x is a real number such that x power 3 plus 4x is equal to 0, then prove that x is equal to 0. We take contradiction. Let x is not equal to 0. So if x belongs to real number as this is given and x raised to power 3 plus 4x is equal to 0. So what happens? This implies, taking x common, x square plus 4 is equal to 0. Again this implies either x is equal to 0 or x square plus 4 is equal to 0. So from here, in the second case, what we see, x square is equal to minus 4. So this is not possible. This implies not possible. Why this is not possible? Again we say the same thing, x belongs to real number and the square of any real number cannot be negative. Okay, so we write here as x belongs to real number, so x square cannot be equal to negative quantity. Okay, so what is the meaning? The meaning is, conclusion is x is equal to 0, but we have taken the contradiction, that is x is not equal to 0. So our supposition is wrong. What was our supposition? That x is not equal to 0 implies x is equal to 0. Okay, so this was the method of contradiction. Now next one is method of contrapositive. Contrapositive mean, we shall prove the question like this: negation of q implies negation of p. So here, what is negation of x is not 0, x is not equal to 0 implies x into, we say x into x square plus 4 is not equal to 0. This means x cube plus 4x is not equal to 0. So negation of q implies negation of p. So this way, what is the meaning? This is proved. Okay, this is called method of contrapositive. Okay, now next question. Question number 2. Show that the statement for any real numbers a and b, a square is equal to b square implies a is equal to b, is not true by giving a counter example. Of course, suppose a is equal to 2 and b is equal to minus 2. So a square is equal to b square, that is 2 whole square is equal to minus 2 whole square. But cancelling the square, this does not imply 2 is equal to minus 2. So this way, this implies a square equal to b square implies a is equal to b is not true. Okay, now next question. Question number 3. Show that the following statement is true by the method of contrapositive. P is the statement: if x is an integer and x square is even, then x is also even. So first of all, this is the second statement: x is also even. And what is the first statement? This is the first component of the statement. Okay, so this is, suppose this is p1 p2 and this is the statement p1. Okay, the question is p1 implies p2. Now how to prove what is contrapositive? Contrapositive means negation of p2 implies negation of p1. Now what is negation of p2? Let x is not even. Okay, that is equal to, not even mean odd. Odd mean 2n plus 1 c. So what is square? X square is equal to 2n plus 1 whole square. This becomes 4n square plus 4n plus 1. Again we take 2 common, this becomes 2n square plus 2n plus 1. Again this is some integer 2n, this is also like of this form 2n plus 1, that is odd. That is, x is an integer and x square is even, so x square is also not even. So what is the conclusion? x square is not even. So this was the contradiction, contrapositive. Negation of p2 implies negation of p1. Negation of p1 mean x square is not even, right? Now next question. Question number 4. By giving a counter example, show that the following statements are not true. Statement first, P. If all the angles are equal, then the triangle is an obtuse angled triangle. Of course, this is false. This is false, as all angles are equal. That is 60 degree plus 60 degree plus 60 degree is equal to 180 degree. This is the triangle, equilateral triangle. Or so not a single angle is greater than 90 degree. So this means this cannot be obtuse angled triangle. Obtuse angled obtuse angled triangle mean at least one angle should be greater than 90 degree. Second part, Q is the statement. The equation x square minus 1 is equal to 0 does not have a root lying between 0 and 2. So by giving a counter example, show that the following statements are not true. So what is the counter example? Let x is equal to 1 be the root of x square minus 1 is equal to 0. So this is satisfying. 1 whole square minus 1 is equal to 0. This is true. Therefore 1 is the root. But what we say, 1 belongs to 1 lies between 0 and 2. So this statement is false. Now next question. Question number 5. Which of the following statements are true and which are false? In each case, give a valid reason for saying so. Number 1. P. Each radius of a circle is a chord of the circle. This is false, because radius mean from the center of the circle to the circumference of the circle. That straight line is called radius. Whereas what is chord? Chord mean intersecting the 2 points on the circle. So this statement is false. Now next, second part, Q. The center of a circle bisects each chord of the circle. This is again false, because what is the meaning of chord? Chord mean we have this. Chord is intersecting the circle at 2 points. So the center of the circle bisects each chord. Here is the center. So center of the circle is not bisecting the chord, this chord. Okay, so this definition, this statement is false. Now third part, R. Circle is a particular case of an ellipse. Now what we know about ellipse? Ellipse equation is x square upon a square plus y square upon b square is equal to 1. Now if we put a square is equal to b square, that is if we put a is equal to b, then this becomes x square plus y square is equal to r square, the equation of the circle. So this statement is true. Now taking part number 4, S is the statement. If x and y are integers such that x is greater than y, then minus x is less than minus y. We know that if 3 is greater than 2, then if we put minus sign to both sides, minus 3 minus 2, then sign of inequality get changed. So accordingly 3 is x. So what we say, x is greater than y, so this implies minus x is less than minus y, so this is true. Now last one is T is the statement square root of 11 is a rational number. We shall prove this with the method of contradiction. Let T is the statement square root 11 is a rational number. Okay, again we suppose here let square root of 11 is a rational number. Okay, now if this is a rational number, so each rational number we can express that number in the form of a upon b, where a and b are integers and they are co-prime to each other. Co-prime means there is no factor which is common in between a and b. Okay, now squaring both sides, what happens? 11 is equal to a square upon b square. Again this becomes a square is equal to 11 into b square, right? This means 11 divides a, right? So we can write a is equal to 11 into some integer m, right? So again what we do, we take the square, therefore square a square is equal to 11 square is 121 into m square. Okay, now we put this value here, this value is substituted here. 121 m square is equal to 11 into b square. Again what we say, we divide both sides by 11, then this becomes 11 into m square is equal to b square. The situation again becomes like this. Okay, the meaning of this is again, what is the meaning? As we wrote here 11 divides a, now we shall say 11 divides b. So what is the conclusion? We are saying that 11 is dividing a, 11 is also dividing b. That is we get contradiction, we get contradiction. Now what is the contradiction? Contradiction is this, that we supposed here square root of 11 is equal to a upon b, where a and b they are co-prime. There is no number which is common in a and in b, but here we are saying, we are concluding that 11 is common in a as well as 11 is common in b. Okay, so we get contradiction. Why this contradiction? Because our supposition was wrong, because we supposed wrongly. With contradiction, with contradiction, this implies square root of 11 is a rational number. We cannot say this is not a rational number. This is the correct answer. So what about this statement? This statement is purely false. That's all of this exercise. Thank you for watching. Thank you very much.